Alright folks, welcome to another edition of the Binding Status. I'm excited to be back, and this is going to be a really fun episode. I think we're going to do some really cool stuff. We're going to be working with a number of different open source projects, and so a lot of them from the OpenFast community. So it looks like we already have some OpenFast community members here. Alistair Hay, looks like he's joining from the UK. Thanks for tuning in. We've got Steven, who's joining from Florida. Steven works on Crossplane. Thanks for joining, Steven. And we've got Jared from San Diego. Jared's one of the founders of the Crossplane project. And Phil from Seattle. Phil also does some work on Crossplane. So we've got some good folks here. Looks like we've got 11 on right now. As I said in the chat, please feel free to go ahead and introduce yourself, tell where you're from, tell why you're joining, and also ask any questions as we go along here. This is a pretty exciting demo. There's going to be a lot of different moving pieces. Oh, it looks like Alex is on here as well. We're going to be using a lot of stuff that Alex has worked on. And I really appreciate he helped me a lot with getting this tutorial ready. So I am super excited to have him on the call here. And yeah, so I'll make sure to point out and give attribution whenever we do anything that's by anyone who's on the call or anyone who's not. So should be pretty exciting. All right, well, I'm going to go ahead and get started because this is actually a pretty lengthy tutorial we have here. And as always, I'm in the my local TBS repo here. So all of this will go up for you to try out at home after the show is over. And so you can run the same type of setup. And I'll try to include an architecture diagram here before I post, or maybe follow up with one, just so that it's more clear what we're actually doing, because there are kind of a lot of moving pieces here. But with that, let's go ahead and get started. So there are a few prereqs here, and I've run through this a few times, so I may kind of like install something that's already present just to show going through it. But essentially what we're going to do is I have this Raspberry Pi here with me in my apartment. And what we're going to do is we're going to first show the new Ketchup, which is k3sup, which is a project Alex works on and the rest of the OpenFast community. We're going to show how you can now install Crossplane in a K3s cluster onto a VM on GCP. So we're going to do that, get the Crossplane control plane running, and just show kind of some ease of use there. We're then going to install K3s on the Raspberry Pi and show that we can connect to it. And then we're going to use inlets both in the cluster on the Raspberry Pi and on the Raspberry Pi itself. So we're going to expose it through an exit node on GCP and then be able to connect to it from our Crossplane control cluster. So there's going to be a lot of moving pieces. I think when we're going through it, it'll make more sense, but it's kind of hard to describe right off the bat. So let's just go ahead and get started with doing some stuff. So first you need to have Catchup installed. So I'll go ahead and open this up here, and so you can see where this lives. So this is the Ketchup repo. So essentially what it does is it's a CLI to allow you to install K3s, which is kind of like a lightweight distribution of Kubernetes from Rancher. It makes it really easy to install it, as we'll see. And it also allows you to install some apps. So if we scroll down here, you'll see a list, I believe, of some of the applications you can install. So we're obviously going to install Crossplane in this demo, and we're actually also going to install the Inlets Operator and do some cool stuff with that. So let's go ahead and get started. Alright, so I'm just in the local repo for TBS here, and let's make sure that I do have yep, I have Ketchup installed, so we can go ahead and get that going. What we're going to do first is install K3s on a GCP VM, and then we'll install Crossplane, then we'll set up the Raspberry Pi. So I've got my VM instances open here. So these are just for some GK cluster that I'm running. So we don't have any instances present. So we're going to do everything from the command line so it's reproducible for people at home. So first thing we're going to do is create a firewall rule that allows us to open up 6443 on our VM. That's where our Kubernetes API server is going to be exposed. So let's go ahead and do that. This takes just a moment here. While we're doing this, it looks like we have Cello, I believe. I apologize if I'm getting the pronunciation wrong there. Cello Spring from Switzerland. Thanks for joining. We're glad to have you here. All right, so we created this firewall rule, and we're going to use that on our VM that we create here. So we're going to call this VM control. And as you see, we're going to add a tag that makes that firewall rule be applied to it. And so that's going to create for us. One thing I want to point out here is a lot of these commands that I'm running to get Ketchup working with GCP are from a tutorial that's going to be linked here that is from Stark and Wayne. So they have a pretty cool tutorial for getting actually a multi-node setup of K3s on some GCP VMs. We're just going to do a single node cluster today, but a lot of these commands are from that, so please check that out, and it's a really great tutorial for you to view as well. Alright, so let's see here. It looks like we have our VM running. It's got an external IP. So what we want to do is just install K3s on this cluster using Catchup. So this is walking through here how you could connect to the cluster. So we can just show how to do that real quickly. So go ahead and set that up. And I've already run the config SSH, so I should be able to now access it. Potentially. And Alex mentions here in the comments that Ketchup can also do the multi-master setups. Yeah, and that's some really cool functionality that mentions a little bit in the docs, so definitely feel free to check that out. Looks like we're having a little bit of trouble here connecting. Oh, I know what the issue is. I didn't update the IP. Just using the example. So make sure to update that, and now let's see if we can get in. Alright, so it looks like I need to run the SSH config again. Alright. Nope. Host key verification failed. Well, this actually isn't necessary, but let me see if I can get this going with just the gcloud command here. So we've run into our first issue here. Alright, I bet, so I'm in the cluster now, or in the VM now. I bet if I do it now, oh, okay, yeah, the known host. So I think Alex mentions updating the known host there. I think that it's still going to do it. Oh, run the command given to you. Alright, so Alex and Alistair are helping me out in the known host, so I really appreciate that. And I will continue on. This is one of the benefits of having more people on the call, is that we get more troubleshooting, so I appreciate y'all. All right, so now let's go ahead and install K3s on this VM. All right, so we're going to use the SSH key given by the Google Compute Engine SSH file and my username. So we should be able to access it. And it appears it's working here, so we'll see K3s being installed. All right, so it looks like it worked for us. And it's created a kubeconfig for us as well. So if we look here, we've got the kubeconfig file. We're actually going to have a few different kubeconfig files throughout this tutorial, so I'm actually going to rename this one. So we'll see here in the guide that we want to call this kubeconfig control. And then we can go ahead and set our kubeconfig to use that when we talk to the cluster. Alright, so rename that, and then we will export the kubeconfig, and we can just do. So now we can see that some of the pods are getting started up here on the control cluster. So it's about ready. It looks like the traffic one is still getting running, so it looks like we're good to go now. So as I mentioned before, this control cluster is going to be where we run Crossplane. So we can now, due to a new addition to Catchup, run and install Crossplane using Catchup, which is kind of just an easier way to configure it. So that's really nice. And here's an example command to do so. So it's just going to use whatever our kubeconfig is set to here. So it's set to this control VM. So if I run this, we should see that Crossplane is installed. It looks like we have an issue here. Oh, okay. And I'm getting some notes about the connection information being exposed. I will clean these up very quickly following this, so I'll make sure to do that. All right, so the kubeconfig control, it looks like, is not working for me here. All right. So config not found. Oh, it's because I did not set it. I need to set it to the absolute path here. I think this will do it for us. Let's try it again. Kubeconfig control. I can see y'all's comments in the chat, but the video is a little bit delayed. Oh, after the PWD. All right. So I apologize for the delay in responding. I can see what y'all say, but it comes in a little bit late. So, all right. Let's try this again. All right, here we go. It seems to be working. So it's installing Crossplane into the cluster. Yeah, and I keep getting some Slack messages about that y'all are helping me troubleshoot, but they do come in a little bit late for me. So here we're installing Crossplane into the Crossplane system namespace. And you can see both the Crossplane pod and the Crossplane stack manager are running here, and they should come up, so we're good to go here. So let's see what's next. All right. So we've got all of the Crossplane stuff set up here, and now we're going to move on to working with the Raspberry Pi. So as I mentioned before, I have a Raspberry Pi on my local network. So I'm going to quickly SSH into the Pi, so you can see that I have connection here. I actually already have Inlets installed on here, which we're going to use later. But first what we want to do is just install K3s, so we have a Kubernetes control plane on the local Raspberry Pi. So we'll hop back over to the guide here, and we are going to, I'll go ahead and export that. And we'll, just like we did on the GCP VM, we are going to install K3s on the Raspberry Pi now. So you'll see that I'm passing in the Pi IP and just using the user Pi, and we should be able to once again see that K3s is installed. And it looks like Muvafik just joined. Muvafik works on Crossplane, and he's joining from Turkey. Thanks for joining, Muvafik. Let's see if I missed anyone. It looks like Nunix joined a little bit late, so we're happy to have you here. I don't think I missed anyone else, but I'll continue to keep an eye on it. All right, it's taking a minute to get started up here on the Raspberry Pi. So while that's happening, we're going to look ahead. So once again, I'll show you that we can connect to the Kubernetes control plane running on the Raspberry Pi. And then what we're going to do is merge our two kube configs so that we can easily switch between them and talk to both the clusters. And then we'll move on to installing the Inlets Operator. And let's see if it's up now. It looks like it is. So once again, we have some nice kube config information being exposed there. At least this is on my local network. And we're going to do that, and then we'll set the kube config again to kube config remote, and let's see if we can see our Raspberry Pi. Yep, so we can see that we have a single node Ketchup, K3s installation here running on the Raspberry Pi. I'm going to go ahead and merge our kube configs here. So they actually have similar kube configs that's just set as the default user, which is the default behavior for Ketchup when it installs. So I like to replace them with different usernames, because that allows us to have the different contexts sorry, not different usernames, just different contexts. So that allows us to merge them and then switch between them, and kubeconfig can identify the difference. Sorry, kubecontrol can identify the difference. All right, so now we should be able to get our context. So now we'll have control and remote. So if while I'm on control, you can see this is the VM where Crossplane is running, and then if I use context remote, and let's get the pods. You'll see that we're just looking at the Raspberry Pi installation here. And it looks like Alex is pointing out in the chat that Ketchup can actually do this for you. So there's a lot of good features that we're not going to cover completely throughout this, but there are a lot of different flags and stuff you can pass to Ketchup to get some of this functionality enabled for you. But some of it I will be doing manually, but we'll try to use as much as possible. So what I want to do now is set up Packet with the Inlets operator. So actually here, let me look at the preview so we can just click these links. All right, so I said I would mention the Inlets operator earlier. So the Inlets operator essentially runs in your cluster, and it will provision exit nodes for you to serve as a load balancer for your services. So this is really cool for something like a Raspberry Pi. It's not exposed to the public internet, and so it adds a lot of functionality if you're doing something within a local network. So I definitely encourage you to read up on this a little bit and look at some of the tutorials that are already mentioned here. Once again, this is something that Alex works on in the OpenFast community. And it's a really cool tool, and we're going to be using it a couple different times throughout this. All right, so as I mentioned before, we can actually use Ketchup once again to install the Inlets operator. So we're going to do that on the Raspberry Pi cluster. And to do that, we're going to need to use my Packet project and Packet API token to allow Inlets to, when it sees a service be created, provision a new node, a new machine on Packet, and then route traffic through that and to publicly expose it. So let's see, we're going to, I have my my Packet project here in my directory. So I'm going to assign that to this variable, and then I also have my Packet token, and we'll do that in the actual command here. Also, Alex mentioned another project here in the chat, Cube Context, which is really helpful for doing some of the switching between different contexts that I was mentioning. So definitely check that out. It's another cool project. All right, so as you can see here, we're specifying that we want Packet to be the provider. You can also use DigitalOcean, GCP, a number of different things. We're specifying the region we want the exit nodes to be provisioned in, and then just some information for the operator to be able to talk to Packet. So you can see here that Ketchup is installing, and it looks to be successful. MoveOffit mentions that he's been looking for something like the Inlets operator, so I'm glad that this identified that for you. I've been playing with it a lot, getting ready for this demo, and it is super cool. I've really enjoyed working with it. So you'll see here that the Inlets operator is running. And if we, which we will do later, create a service in this cluster that specifies a load balancer, then it's going to pick that up and it's going to create a machine here on Packet for us. So we'll see that later on. Okay, so the next thing we're going to do is port forward the Kubernetes API server using Inlets Pro. So the Raspberry Pi is on my local network. And so obviously what we want to be able to do is schedule applications from the Crossplane control cluster to the Raspberry Pi cluster, but this VM where Crossplane is running is not aware of the Raspberry Pi. It doesn't have a public IP address, so we need to set up a proxy to make that work. So what we're going to do is go ahead and set up another GCP VM, and you could do this on any VPS provider. But I'm just using GCP since we were already on it. And once again, I'm going to create a firewall rule here, which is basically going to allow for the port forwarding and also for us to access the API server. So it's going to open up some TCP ports on the actual machine. So let's go ahead and create that. And while that's happening, we'll go ahead and grab our other command. So I'm calling this a Pi Proxy, this instance, and it's going to have that tag that opens up the ports for us. And when we actually do the port forwarding for the Kubernetes API server, we're going to use Inlets Pro. So Inlets itself, the open source project, allows you to be able to do layer 7 proxying, but Inlets Pro actually allows you to do TCP proxying, which is super helpful for something like this. So Alex actually was generous enough to let us try that out here, and that is going to allow us to port forward this Kubernetes API server. So you can also get a free trial if you just fill out a Google form that they have there on the Inlets Pro repo. So definitely look into checking that out. So once again, we have a VM running here. And so now it looks like I actually left this step out here, but we are going to use the same command as above to SSH, I'll just do it manually, into this instance that's running. And once we're in there, once again. All right, here we go. So we're in here again. And what we want to do here is install Inlets. So I mentioned that we installed the Inlets Operator into our Raspberry Pi K3s cluster, but we also want to use Inlets for the actual forwarding of the Pi to this VM. So we're going to use it outside of the Kubernetes context here. And so I'm going to go ahead and install Inlets CTL or Inlets Control or Inlets Cuddle, if that's how you pronounce it. And you'll see we have this here. And now we are going to go ahead and set this up. So first we need to download Inlets Pro here. And lastly, we will get this running here. So what we want to do is run this server and automatically create a TLS cert for us. And then we want to go ahead and put in the Pi IP so it knows what to forward to. All right, so the token, we actually haven't set up the token here. I'm actually going to do a bit of this off screen here, just so that we don't share all the information, but essentially I'm just setting these environment variables to tokens that are accessible. This is a little bit overkill considering that we did just show full kube configs there, but that's okay. So I'm just going to set the token variable, and we should be good to go after that. All right. And we also need the Pi Proxy IP and the Pi IP. I'll just manually enter those here. So I see Alex mentioned that the auto TLS command is missing there. From what I understand, it actually, and I'm sure you know this better than me, but I think that it defaults to true here. So I don't think that's going to be an issue for us, but it wasn't an issue when I was going through the tutorial earlier. But if it does, then I will obviously correct that. I want to look back up here, and I know this is the IP of my Raspberry Pi. And the common name we want to be the GCP VM. So let me just grab that from here real quick. So this Pi Proxy, we want to use that. All right, and this should get the server running for us. So we're all set up here, and I am going to go ahead and split this here. Oops, sorry about that. So I'm going to need to run this in the background. Hold on one moment. I'm going to stop that for a second. And I'll exit here. Oh, I'm still from here. Hold on one moment. Let's go ahead and just split it like this. I know I could also run it in the background, but all right. Enter a common name. Well, I do have a common name here, it looks like. Interesting. Oh, I bet the token var did not get set. Let me move that over again. All right. So we are all up and running here, and let me switch down to this other terminal here. Actually, I'm going to close this one, and I'm going to split this vertically here. All right, so next thing we want to do is SSH back into the Raspberry Pi. So we can do that as I mentioned above. So all right, so I'm in, and Marcus has a good tip here for exporting the token there. Which I should definitely do next time we have a tutorial like this. All right, so now we have SSH'd into the Raspberry Pi, so we want to set up the client to run here. All right, so a little farther down the guide here, I've written how to set up the client. So I actually believe I already have Inlets control and Inlets Pro, and so let's see. Yep, so I have Inlets Pro, and so what I need to do here is use that Pi Proxy IP. So that is going to be the IP of the VM, the external IP. I'm going to use that same token, and then I'm going to use a license which Alex has shared with us is a temporary license that's going to allow us to use Inlets Pro here. So I'm just going to hop this over here again to do this quick setup. And let's see here. Alright, so I'm going to set the Pi Proxy IP to that of the VM here. So let's see, export. Alright. So just to commentate on what I'm doing, I'm just setting the token, Pi Proxy, and license variables just so those don't get shared out here. Although I did realize that even after setting the token privately in the previous step, it does get printed in the logs, so that doesn't necessarily help there. But I don't think that the license will get printed here. But if it is, at least it's temporary. All right. So now we should be able to jump back over here, and I will copy the command to get the client running. Oh, that did not clear. Very sorry about that. Well, I guess I need to clear it again. Alright, so it looks like we have set up the proxy correctly. And so we should now be able to connect to our API server from any other remote location. So what I'm going to do is I'm going to take the kubeconfig for the Raspberry Pi, and I'm just going to update the server with the IP of the VM that we just set up as the proxy, and then I am also going to add this insecure to skip TLS verify so that our kubeconfig skips trying to make sure the cert is valid, because it is just a self-signed one. And it looks like Nunix has a question here. Is the exit node only possible with a cloud provider, or a local instance could also be used? Yeah, anything that had a public IP address would be possible there. And Alex, you're obviously welcome to follow up on that further if you want. But, all right, I am going to hop back over here. And all right, and I'm going to copy this kubeconfig remote into kubeconfig proxy, and we'll see here that this kubeconfig proxy has been set up, and now I am going to do those replacements that I mentioned. So this is the IP here of our external server. So I'm going to replace that as the guide suggests. And I'm also going to add the insecure TLS skip verify, or skip verify TLS, so that we don't try to do that. And we could obviously just add that at when we're using kube control to talk to the cluster. But the issue with that is that we're actually going to load this kube config into Crossplane and then use it to provision to it, and so we wouldn't be able to do it in that case. We wouldn't be able to provide it at command time, if you will. All right. So I've just about got this set up. All right, and I'm going to go ahead and merge this also into my kube config here, and that's going to allow us to talk to this cluster through the proxy. So let me grab that one more time. So I'm just going to add this on, we called it kube config proxy. So now let's see, config get context. Oh, it looks like I did not get it added there. Merge kube config control. Huh. That is unexpected. Interesting. Let me make sure I have this right here. So we have kube config proxy. Merge kube config control, kube config remote. Weird. Oh, it's because I need to, I see. I need to update. As I mentioned before, it has the duplicate since we just copied it from the remote. So I need to update the context there as well. So this is probably maddening for any viewers who are in the comments providing the solution right before I actually do it because of the delay. So I'm going to update remote to proxy in each of these, or sorry, just in the kube config proxy. All right, now let's export that and see if we can get our context now. All right, so we've got proxy, remote. So remote is once again connecting to the Raspberry Pi on our local connection. So we can see that there with the Inlets Operator running. And let's do use context. And let's try out that proxy connection. So hopefully this works for us here. And we should see the requests. So we see the request there. And we are now able to access the K3s cluster, the API server there, from anywhere. And that includes from the control cluster itself. So I'm going to move this back over here. And the next thing we're going to do is demonstrate how you can schedule to any Kubernetes cluster from Crossplane. So what we want to do is connect back to the control cluster. We are going to create a secret by base64 encoding the actual raw kube config that we just created for communicating through the proxy, and then setting up a secret with that in it. And then we're going to create a Kubernetes target, which is a Crossplane concept that points to that secret. And then we are going to schedule a Kubernetes application, which is how you basically package up different resources. We're going to schedule that to the Raspberry Pi cluster and see how that comes up. All right, so first thing we want to do is go ahead and set this variable here. So we have that set, and then now we can just easily create the secret here. And we should see that there's a secret.yaml now. So before we create that, I want to go ahead and, sorry about that, switch back over to the control cluster. And so let's make sure that we're in the place we think we are. So Crossplane should be running here. Yep. And so what we want to do first is create that secret. Also, this kind of, I mean, it's pretty simple to create the secret and embed the raw kube config in there. That was actually an update that Movafic added probably 2 months ago to be able to use the raw kube config. So we use that across stacks now in Crossplane. So that makes it a lot easier rather than like manually translating fields into the data part of the secret. So shout out to Movafic who's on this call for that. But we're also looking at adding that to the Crossplane control CLI and making that a little bit easier to use. All right. So I'll create that secret. API version not set. It looks like I accidentally omitted that, so let me correct that real quick. Well, I can actually just add it later. If we want to add this at the top here, I'm just going to manually edit the secret directly. And I'll make sure to update that in the actual guide so that it works for everyone. So all I'm doing is just adding the API version v1 at the top of it. So let's see. All right, so now our PyK3sup secret is created. Maybe it should have been Pi keys, but we'll go with that. All right, so now we're going to create the Kubernetes target. So this is going to be in the default namespace, and all we're doing is pointing right at that secret and saying, use this when we get scheduled to this. All right, and it's just target here. All right, so that's created successfully. And the next thing we want to do is create that Kubernetes application. So for the simplest setup, I just want to show that we can schedule the creation of a namespace to the Raspberry Pi. So that's pretty simple. It doesn't show the functionality of the Inlets Operator being installed there, but we'll build up to that over time. I just want to show that this Crossplane cluster is able to create resources in any arbitrary other cluster. So I'll go ahead and create this. And hopefully I don't have any errors in that manifest. And we can just go ahead and I think it was app.yaml. All right, so it looks like it was created. We also saw that it looked like there was a connection made to the Raspberry Pi cluster there. So let's take a look at the status of this Kubernetes application here. So it looks like it was scheduled, but it hasn't been submitted yet. And if you're not familiar with Crossplane, you can, when you create a Kubernetes application, each of the components in it, which we just had one in this case, results in a Kubernetes application resource. So now we see that it has been submitted. We can actually look at the output of it. And it looks like it's submitted, successfully reconciled, and active. So let's look back up at the Kubernetes application, and you'll see it submitted. So we're good to go. But to actually show that this was created on the Raspberry Pi cluster, let's once again connect, and we can just do it via our local connection to it. And you can see this TBS 9 namespace was created, which is pretty cool. All right, but, and this is a bit of a stretch goal here for the demo, but I think it would be super cool. What I want to show is actually provisioning a deployment and then creating a service for that. And when we do that, the service is going to have the Inlets Operator create an exit node on packet, because we gave it credentials to do so, and it's going to spin that up for us, and we should be able to get a publicly accessible deployment of this Hello World app. So I haven't run this one yet, so we'll continue the live demo theme here, which we like to embrace here at Crossplane. And I'm going to go ahead and create this. All right, so this is app2.yaml, and we'll see here how it's going to work. But one thing I wanted to point out before we do that is that the way that it's getting scheduled to this specific cluster, so if we had multiple, we could, let's say we had 10 Raspberry Pis here that all were publicly accessible, or we had a Raspberry Pi and a GK cluster, etc. It's scheduling based on labels here. So when I created the target up here, I put this label TBS 9. So we're basically saying on this Kubernetes application, I'm fine being scheduled to any Kubernetes cluster that's represented in my namespace that has the labels I provide here, which we just did the one. So let's now see if we can get this going. So we are going to create the app2 here. Kubernetes application. Oh, well, we'll see my first issue. I didn't switch context back here. And we want to do control. All right, now let's try it. All right, so it looks like it was created, and we'll see if we are successful here. If I can spell kube control correctly, that will likely help us. All right, so they are scheduled, so that's definitely positive. And let's see. Looks like they're now submitted as well. And what we should be able to see is the IP address that's assigned to the packet node, which is our load balancer essentially here, our Kubernetes load balancer, should come up in the test app service here. So let's do test app service and see how we're coming here. So it looks like we have been giving an IP here, and let's cross our fingers and see if this works for us. I will say I'm pretty proud of the timing here, because we have 5 minutes left and we are about to wrap it up. But it looks like this was not successful for us. This could be because the server is still being provisioned, and that does look like the case. But you'll see here that a packet server was automatically configured using the Inlets Operator that we installed in the K3s cluster on the Raspberry Pi, which allows me to now have these public-facing services on the internet. So that is pretty cool. It looks like that the IP assignment is a little bit off here, and that is likely something on Crossplane's side that has to do with how the Inlets Operator is provisioning the service. So I'm guessing that's just how it's propagated back, because this is the local IP of the Raspberry Pi. So we're getting the welcome to Nginx here. Okay, there we go. I think that was just cached. So it might take a moment here for this to come up. Let's see. So it looks like it just came available. And we are loading here. I wonder if this gets updated at all. Yeah, it's just sticking with that. So like I said, I'm guessing that's having to do with the way the service is being provisioned. And I am going to take a look here at the actual Raspberry Pi and see. Alright. So we have external IP. Interesting. So I think this is why that it's showing both of these here. And we just want this one. And so let's try on 8080 here. So we do have the service running. And Alex said he'd be happy to debug with me. It's a pretty complex setup. It definitely is. I am interested to see if we can do a little bit of troubleshooting here. So yeah, the external IPs are there. So interesting. I believe it should also be on the local network, which we can try. So Alex also mentions that we have a conflict with traffic, which I believe that I deployed without traffic. So yeah, I did a deployment and excluded traffic when I was installing K3s here. So let me try this and see. If local. So I'm going to try this one more time. And this is likely just due to the way that we're set up here. So there may be a way to troubleshoot this. I'm sure Alex will probably have it figured out by the time this call ends. But you can see that this does work in terms of scheduling workloads there. We may have to refine how it works with the Inlets Operator. But we can show, if we want, let's see. I know on the Inlets Operator here that they have a, oh, that's not what I meant to go to. That they have an example of running an Nginx one. So we're just going to create this directly on the Raspberry Pi. So, and we'll see. I just want to demonstrate how it actually works here. All right. So that could definitely be an issue. We have a crash loop backoff in the actual provisioned container here. So I'll show this. Well, it looks like that it's caught up now. Let's look at the logs here. So this is likely an error on my part here. Exec user process. Exec format error. Interesting. I'm gonna try one thing here. See if we can get going. I don't think that this would alter anything, but it's worth a shot. Earlier I ran it with 2 replicas, and alright, I'm going to edit TBS 9.2, and we can scroll down here. I see. Alex noticed. So the issue here is that I'm running the wrong binary here, the wrong build. So Raspberry Pi is ARM, and this is is ARM, excuse me, and I'm running an Intel binary here, so it's not going to work for us. I wonder if they even have a, let's see, I'm looking up here if we have a GCR hello world that is for ARM. Interesting. So I'm going to go ahead and delete this. And we're going to try an ARM build. So let's give it a try here. Alright, so let's just create a new file here. We'll call it app3 YAML, and I'm just copying this over. So let's once again update this. So we're going to need to put this into our Kubernetes application. So I'm just going to copy paste this up here, and we'll replace this template and let's see, I'm going to do app TBS 9.2 here, and we can just do one replica, and then we'll want to create a service for this as well. So we're going to make the target port here. Actually, we'll make this target port 80. we need a selector, so we put app TBS 9 on there, so yeah, app TBS 9 too, so we should be good in that regard. We can still call that hello world service. And, well, actually, let's update this. We can just get rid of that, I believe. All right. So we should be good to go here. So let's give it a try. I'll check over in the comments. Marcus says, I'm addicted to the live demo rush. I just like learning in public, I think. So, hopefully, my mistakes can help others learn. Alright. Now, let's see how this progresses. Scheduled, that's positive. Submitted, that's also positive. It's highly possible that I have a error in here somewhere, so we will go ahead and make sure to monitor that. Another thing to mention is I could have looked, I should have done this before deleting, because that pod did not start successfully, the status would have been updated to failed here. So we could have done that all without looking into the Raspberry Pi at all, but it is kind of nice to be able to see that. All right, and so we're getting another Hello World service tunnel here. So you can see that the other one was cleaned up and we're provisioning a new one. So that is nice to see. And let's take a look. Well, it's not ready yet, but should be pretty soon. Packet boots up its servers pretty fast. And let's hop over and let's see, use context remote. And I'm going to see what we have here. Huh. So it looks like the external IP, oh, it's probably just going to pop up with once it is done provisioning, potentially. Let's also check our pods and see if that started okay. Nope, still getting an error. Alright, we may not get it done in this one. So it looks like the container I used for this one also is not compatible with ARM. So we might just have to skip this for now. But I am addicted to the rush of of the live demo, as Marcus says, so I don't want to quit on it. Well, I know this one is supported on ARM. Well, maybe not ARM HF though, huh? Interesting. Let's see. There is an ARM HF Hello World. Oh well. We'll make sure to get this updated. Yeah, and Alex mentions that you can run it directly on the Raspberry Pi. That's definitely true, and I'll do that quickly just to show how it can be done. Oh, I'm already on the remote. All right. So I'm going to go ahead and just pull from the Inlets tutorial here and just create these Nginx ones here and show you that it will in fact do this successfully. Just to make sure y'all know that Nginx is, Inlets is a great project. I do want to show how this can be done. All right. Okay, so it's pending here. Let's update this and see if we've got a new exit node being provisioned. Yep, here's our Nginx 1 tunnel. So this is working correctly. So once again, the Crossplane way of doing it as well would work if I got a suitable binary to run with it, apparently. But I would imagine that this Nginx one should work. So I don't know, we'll see. But this should come up pretty quickly, and we can see how it's working. Looks like we're pretty far over time, so once this comes available, we'll probably go ahead and call it a day here. All right. This one is taking a little bit longer than usual. While we're waiting for it, I do want to call out all the projects we used here. So Inlets Operator, we used Inlets Pro, Inlets Control, so lots of those. You can check out any of the inlet stuff there. OpenFast kind of has a relation to all of these projects, so definitely check them out. They have links to their Slack and different community and GitHub as well on here, and you can do some really cool stuff using OpenFast. One K3S, so this is what we're running, is our lightweight Kubernetes. So this is from Rancher. They have some nice documentation. It's also just a great project to look at if you're interested in learning a little bit more about Kubernetes architecture, because it's kind of simplified. So actually looking through the repo is kind of fun. You can take a look at Ketchup, which is what we used to install K3S, Inlets Operator, Crossplane, and this is a pretty awesome project that's continuing to grow in functionality. And then lastly, of course, we use Crossplane. So we just scraped the surface a little bit, but the ability to provision to any Kubernetes cluster is pretty cool. So definitely check that out and try it out some more. We've got a lot of new stuff coming in Crossplane in the next few releases, so there's some cool things to watch here. We didn't show the ability to provision managed services using Crossplane, but we basically could have done this whole demo from an existing Crossplane cluster by spinning up, VMs or Kubernetes clusters or what have you. So maybe we'll show how to do that in a future one. And I bet this is ready now. So let's hop on over. And we get the Nginx homepage. So shout out to everyone over at Inlets who works on this, especially Alex. Thank y'all all for joining in this tutorial. And Alex mentions, I see that he'd like a diagram for this, so definitely we'll do that and get that posted on Twitter and stuff as well. And if anyone has any questions, always feel free to reach out to me directly or join us in Crossplane Slack, and just let us know what you're up to and what your interested use case is. So with that, we're signing off for TBS this week, and thanks to everyone for joining us.